So now we get into the nuts and bolts of standards and testing and certification. What is a documentary standard? Here, again, is a standard definition of a standard. But it's basically a document that captures the best thinking, the prescribed practices, something that you're trying to standardize. Here are some cover shots of some examples. One thing to note is that there are organizations that develop and maintain these and have participants in the stakeholder process, but that takes a lot of effort to do. And so these standards development organizations have business models, and so they'll want you to pay for a particular standard. So standards aren't necessarily free. What are the ingredients in a standard? Oftentimes when technical folks get together and they develop a standard, they're all contributing what they would like to see in that standard. They're not all going to win. Sometimes there's arguments and discussions. So one approach is, just let everything in. There's all sorts of different capabilities that a standard can have. Or you may need to figure out, how do you take that optionality and start to defining it to be something specific that you can implement. This is the process of profiling and getting to testing and certification. And we'll go through this in a little bit of detail. The other thing to note is that this is a process. You develop the standard, then people start implementing it. There's a feedback loop where you learn, hey, this worked, this didn't, I need to update the standard. There's a lot of hard work that goes into this. You need to have, for example, vendors that get together, particularly across vendors, test things out in, for example, plug fests. They're going to test things out in plug fests and decide whether or not something actually works. So they kind of test it to failure. That's kind of the point. You need to have those mechanisms where the community is working together to test out the capabilities of the standard and the systems. So where are these available standards? Can I go find a list of them? The answer is yes. There's various places that you can go look. For example, when NIST was involved with the Energy Independence and Security Act, working with the community to coordinate the development of a framework for interoperability standards, one of the things that we worked on was a catalog of standards, which is now maintained by SEPA. And so you can go online and you can get to a visual representation of the smart grid. And then you can click on any of these areas and you'll get like a detailed list of standards that are applicable to that particular part of the smart grid. And you can dive into it in more and get more information that way. There's also some work related to our framework, and there's a recent tech note that we published that kind of updates our looking at standards. Another very important place is the standards development organizations themselves. They all have websites and maintain very active areas. IEEE and IEC are two of them, and I showed two of their websites here, and many, many more places. So there's all sorts of places for you to go to find the standards, and then you need to talk with experts to figure out how to best implement them. So this was kind of the question that we had in our poll, and the answer is no. Standards are not enough for interoperability. Testing is also needed. You can have different types of testing. You can have conformance testing where you're trying to say, does this product conform to the standard? Does it do what the standard says? However, just because it does what the standard says, if you hook it up next to another product from a different manufacturer, they may not interoperate. Interoperation is a higher bar than simply conforming to a standard. So there's something called interoperability testing. There's some specific tests that you can do to make sure that the systems work well together. The conformance testing does not guarantee interoperability, but it definitely helps. So if you're working just in the Wild West, it's going to be very hard to get the two systems to work together well. If the two systems that you're trying to work with are at least conforming to a standard, that makes it a better ordered universe for them to come to agreement. And if you want to go to a testing and certification process where It's not just enough to say, okay, we'll trust the vendors. Go ahead, implement your products, build them according to standards, and let's see what we get. You may need someone else to come in and say, they did a good job or not. Are you going to trust the manufacturers to make that? Oftentimes they're capable and very, very knowledgeable about the standards. And so they're a very good first choice to go to kind of like go, how is this working? How is your system working with respect to interoperability? But if you're wanting to integrate this into a system with multiple vendors, you may want additional levels. You may want second party where the user is coming in and certifying, or you may want third party where it's an independent organization doing it. But all of these organizations are going to need to have a process. You need this ability to take a standard and figure out its guts and details. So you're starting at the left-hand side here, where you're working from a technical specification from a standards development organization. Then you are figuring out what are the specific things that I want to do in a set of implementations, creating a profile implementation conformance statement, testable statements. It should do X, Y, and Z and not do A, B, and C. You're going to need to have a test specification developed. You're going to need to have test harnesses. What these are basically in a software sense, you can think of it as a software apparatus that goes around and kind of teaches you to the test to make sure that you're doing things right. If you build the software package around it, it will guide your choices so they are in alignment with the standard. Or they may be physical. You may need a physical connection between things and the ability to test it out. And then when you get done with that, you're still going to need to go to this interoperability testing to make sure that it actually works together for the desired purpose. So when you get these agreements where you're kind of limiting the specificity of the standard, you're making choices, we call these profiles, where a profile is, in a way, it has a certain formality to it. It's not just two people get together and decide on something. You need to have more of a community effort. Someone's going to have to kind of oversee this in some way. But the basic elements are you're going to have like a physical performance specification. Oftentimes there's a communication protocol. There's an information model. We talked about the need to exchange information and use it. So you're going to need to make sure that you have a common understanding of that information. And if you get to this profile, if you get to these more specific choices, that will make your testing and certification much easier because it's very specific things that you can then test. And also this could be supported by the vendors in procurements, for example, because it could be more specific as to the type of equipment that you want to obtain. I've already gone over kind of like, the first party, second party, and third party testing, who does what. And there's strengths and benefits to all of these. There are strengths and benefits to all of these. For example, I want to quickly touch on what we've talked about before, Rule 21 for interoperability profiling. California had done a specific rule and made specific choices to get to what's called Rule 21. They picked a particular, in this case for inverters, a particular communication profile and information model. That was in many ways needed. You needed someone to stir the pot to get things rolling. California has been a leader in many other areas. This is an example of them kind of going, hey, we need to meet what our requirements are. This is a way to kind of point the community towards this is what we need. But you also need to have the community as a whole get a chance to look at that and develop it. So for example, over time, you may end up with profiles such as the 1547 interoperability profile, where you pick a certain number of things and you think through it, and here are all the different configurations. It's a broader universe that it can meet. So there's this balance between, say a state may have very specific requirements that it wants to meet. When should it go to a point of kind of telling the community and the vendors, this is exactly what we need, versus having the rest of the pack kind of move along with you so that you can achieve a broader goal? So there's some pros and cons to all of these different approaches. The other thing that I should mention is that there are not enough testing and certification programs. So you may look at all of the kinds of equipment that the regulators are seeing come onto the grid, and there's not necessarily going to be a testing and certification program for everything. We did a survey you can go to in this tech note where we looked at standards and we did an analysis of whether or not there was testing and certification. And in many cases, there were not. Only a small percentage had a testing and certification program. So it takes a lot of work to put these together, which is why they don't just immediately pop up. You need often a trade association or someone that's going to do the work of establishing the testing and certification and all of the different parts to it. So that's something that the regulators need to know, is that you will need to help encourage the development of these testing and certification programs if you're going to rely on them to help your utilities get the value from testing and certification of products going onto the grid. So with that, I will close out this section.